of A plus B. Can I just distribute it and do the cosine of each individually? So to answer this question, let's take a couple angles and plug them in and see. So if I said A was 30 degrees and B was 60 degrees. The question is that the same as the cosine of 30 degrees plus the cosine of 60 degrees? So if I did the first one, I would have to do 30 plus 60, which is 90. I told you before we started this that these values aren't going away. We still have to know them. Some cosine of 90, if you think about your hand trick, fold in your 90, cosine is the square root of the bottom over 2, so that's 0. Over here, cosine of 30, so if I fold in my 30, cosine's the bottom, so radical 3 over 2. Cosine of 60, so if I fold in my 60, cosine's the square root of 1 over 2, or 1/2. Really, all we could do there is maybe write them in one fraction, put 1 in. So are these things the same? No. So what we see right here is we cannot just distribute a trig function if we have more than one angle. So we have formulas for how to simplify that. So if you get out your flip chart, we're going to go to the second page, sum and difference formulas. Today I'm going to give you 2 formulas for cosine. Tomorrow I will give you formulas for sine and tangent. So you'll have a total of 6 formulas that we write on this tab. All of these formulas will be given on the formula sheet. So you do not have to memorize any of them. We just have to be able to use them. So if I ask you to find the exact value for cosine of 75 degrees. So when I say exact value, that means don't give me a decimal. Sure, you could plug that in your calculator and get a decimal, but then you have to round it. So when I ask for exact value, I'm talking about radicals. But 75 was not an angle we memorized on our unit circle. So we don't know what it is off the top of our head. Can I rewrite 75 by adding or subtracting 2 angles that are on my unit circle? So,
45 and 30.
Mm-hmm. Okay. It does not matter what order you write those, if you write 30 plus 45. It doesn't matter if you have a different combination. A lot of times there's more than one option. We will get the same answer. So now I have the cosine of A plus B. So look at your cosine A plus B formula that you just wrote down. And so it tells us you have to do cosine of A. So my A is like my 45 degrees. Cosine of B, B is like my 30 degrees. Minus sine of A, sine of B. At this point, we can evaluate this stuff. So when I say cosine of 45 degrees, what is that? Times the cosine of 30 degrees. Sine of 45 degrees. Sine of 30 degrees. When you're multiplying, if both numbers are under a radical, you can multiply them together. So we get radical 6 over 4 minus radical 2 over 4. And you can leave it like that. Since they have the same denominator, you can write them in one fraction, but you can't actually do the square root of 6 minus the square root of 2 because they are not like terms. So either of those is fine for your final answer. If I had said negative 75 degrees, what would you do first? Add 360 and get a coterminal angle and then work from there. So you could also use like negative 45 plus negative 30 if it were a negative 75. And that will work, but I think most people usually prefer to make your angle positive. So if I ever gave you a negative angle, you could do that. On B, cosine of 17 pi over 12. It is much harder to think about what adds or subtracts to 17 pi over 12. So what I recommend is if it's in radians, change it into degrees. That'll be a little bit easier for you to think about. So how do you convert that into degrees? So the pi's cancel, so you have to do 17 times 180 divided by 12. What do you get? So I need two angles on my unit circle that add or subtract to 255. So if you need to, you might pull out one of your old copies of the unit circle. You should have some floating around. When it's time for a test on this, you are welcome to fill out a blank unit circle if that helps you. I will always have those available. So we're probably not just going to do like 30, 45, or 60 on this one. We're probably going to have to go with some bigger angles.
300 degrees minus 45 degrees.
Okay. 300 minus 45 would work. That's not the only option on this one. You could do 120 plus 135, and that would work. There's several options. Doesn't matter, you will get the same answer, you just have to show me how you're getting there. So this is a cosine difference because they're subtracted. So we're doing the cosine of A minus B formula. So my A is my 300, so we have the cosine of 300 degrees times the cosine of 45 degrees. One thing, we're not plugging in a negative 45 degrees. This minus is what makes me take the difference formula, so we're treating A and B as positive numbers. Plus sine 300 degrees, sine of 45 degrees. Wait, 300, what quadrant is that?
4.
Reference angle?
660.
60 minus 300. So in quadrant 4, is cosine positive or negative? Positive. And what is the cosine of 60? Radical 1 over 2, so 1/2. Cosine of 45? Radical 2 over 2. Sine of 300. In quadrant 4, sine is negative, and the sine of 60 is radical 3 over 2. Sine of 45 is radical 2 over 2. So then if we multiply, we get radical 2 over 4 plus negative, or you could put minus radical 6 over 4. Or you could write it as one fraction if you prefer. Either of those answers is fine. Any questions there? Look at the next. What do we need to do here? Yeah. This is like saying cosine A, cosine B plus sine A, sine B, isn't it? So that is the cosine difference formula, so the cosine A minus B formula. What is my A? And my B? So 173 minus 83 is 90, and what is the cosine of 90?
0.
Does everyone understand how to use these formulas? So you basically just need to figure out your A and your B, and then pick the right one if you're adding or subtracting. I'd like to try, let's do this one. Write this as a single cosine. Cosine 3x, cosine 2x, minus sine 3x, sine 2x. What do we do there? Which formula is this? This is the cosine of A plus B formula. So my A is 3x plus B is 2x, so we just get cosine of 5x, and that's as much as we can simplify it. Let's try a proof of this. Which side would you box in? The right. On these proofs, anytime you have an angle with something added or subtracted, that's going to be the side you want to work with because you have formulas for breaking that apart. So this is the cosine of A plus B formula. So that's cosine of the first, so cosine x, cosine of the second, so cosine 2 pi, minus sine of the first, sine of the second. 2 pi is the same as 0. So what is the cosine of 0? So 1. B squared is 4 over 2, so 1 minus sine of x times the sine of 2 pi is the same as the sine of 0, which is 0. So we get cosine x minus 0, or cosine x. Let's do one more proof. So which side would you box in? We don't have a formula for secant. Yeah. So now we can do the cosine difference formula. So cosine of the first, cosine of the second, plus sine of the first, sine of the second. Okay, if you need to, think about your unit circle. 3 pi over 2 is here. That's the point 0, negative 1. Remember, cosine is the x and sine is the y. So cosine of 3 pi over 2 is 0. Sine 3 pi over 2 is -1. So I get 1 over negative sine x, and 1 over sine is cosecant. So that is negative cosecant x. This is really the end of section 5.3. What I would like to do, I'm going to go ahead and give you the formulas from 5.4. I just want you to write them down on your flip chart, and then tomorrow we'll use them. And then the homework from this section is just 9 problems, so then you'll have time to work on that, okay? So here are the formulas. For sine and tangent. And those are the only ones we're going to get, because if we had cotangent, cosecant, or secant, we can just do reciprocals. So these are the final ones. And then I'll put the homework for 5.3 up here.